Get moving.
I want to go fast.
Cruising fast means climbing fast. In this video, I'm going to tell you why thermal selection is the most important factor in your speed and give you a mental model to help you choose the best ones. What I've learned is, in order to go fast, I need to find the strongest thermals. I knew this for many years, but even the best pilots struggle to explain how to do this, perhaps because they are experts and do it by intuition of experience. I want to give it a shot while I'm actively thinking about it before I forget. First, let's talk thermals. This is how I think of a generic thermal. Near the ground, it's weak since the air is accelerating from zero. As it ascends, it gains speed, but at least in the western US, there's frequently a layer of shear that tears the thermal and makes it hard to climb through. Above that, the thermal again gets stronger until it hits the top of the boundary layer. Now for a second diagram. This shows the climb rate in such a thermal versus altitude. It starts weak near the ground and gets weak again in the shear layer, reaches its maximum velocity, and then tapers off at the top. Since we want to climb as fast as possible, it means we shouldn't get too low where we will spend a lot of time scratching, and we should leave before the thermal tapers off. This is the height band you hear glider pilots talk about. It's the range of altitudes where the climbs are the fastest.
Most people know this, but there's something else that I haven't heard people talk about in the gliding community. The secretary problem.
The problem is this: you want to hire a secretary. There are 10 candidates to interview, and you want to hire the best one. You interview them one at a time, and can either hire them at the end, or you can move on to the next candidate. What is your strategy to hire the best one? If you pick one near the beginning, then you'll be passing up the best candidate with high probability. Similarly, if you interview most of them, you'll almost certainly have passed over the best candidate.
If you want the details, an excellent book is Algorithms to Live By, or see this video from Up and Atom.
It turns out the optimal strategy is to interview about 1/3 of the candidates without giving an offer. Then you hire the first person that does better than all the previous candidates, or the last one if you reach the end. Then you will hire the best candidate about 1/3 of the time, and this is provably the best you can possibly do. As glider pilots, we are in the game of hiring thermals. We want to climb in the best one, and we almost never go back to a thermal we've passed. We don't know how many candidates there will be, but we do know how low we can get before we have to take a thermal. The application of gliding is that we should spend the top third of our height band only cruising and remembering how strong the thermals are that we're passing. We're just gathering information about the distribution of the potential climb rates. In the bottom 2/3, we'll take a thermal if it beats the ones we passed up, or if we have to in order to continue the flight. But to go fast, we need to align the secretary problem with our expectations on thermal strength versus height. The same thermal will often be weaker if we arrive low and stronger if we arrive high, in the same way an interview candidate will sometimes have a good day and sometimes have a bad day. There's no easy way to tell. The bottom of our search range also varies a lot throughout the flight. It's not just how low the workable thermals go, but also what safe land-out options we have ahead of us. If we need to cross a large area of unlandable terrain, then the bottom of our height band must be high enough to safely get us to the other side.
So, in the top third of our height band, we're just sampling thermals to get an idea of the distribution. In the middle third of the height band, we are ready to take a thermal that beats all the ones before it.
But what about the bottom third? Here we should slow down, both because we expect the thermals to be weaker here and also because we are running out of candidates. Imagine we have 10 thermals to choose from, and we are down to the 10th. It doesn't matter how good it is, we just have to take it. In other words, we'll take it even if it's in the 0th percentile. What about just before that, on the 9th candidate? All we know is that number 10 will be better than number 9 with 50% likelihood. So we will take number 9 if it's in the 50th percentile or greater. Now go back one more. We will take number 8 if it's in the 75th percentile. So our threshold for taking a thermal decays exponentially in the bottom third. Many pilots think like this, although they may not state it in these terms or even know why. The rule to slow down and take weaker climbs is a natural consequence of the fact that we cannot keep searching if we land. I also want to mention McCready setting. I'll keep it brief. How should we set it? There are two key insights from Reichman that I don't hear pilots discuss often. First is that you don't have to be accurate. If we fly at McCready 4 but find an 8-knot climb, then we only pay a 5% speed penalty for setting the ring 50% too low. Second, remember that the setting should be equal to the initial or final climb rate, so it should always be less than what we expect to climb in. Imagine you find that 8-knot thermal. As you near the top, what value would it need to decay to in order to make you leave it? Maybe when it gets down to 4 or 5 knots? That is a reasonable choice for the McCready setting. So we need to estimate what lift is ahead based on all the available information, including our experience and eyeballs. Then we cut it down a bit to get the McCready setting. This gives a very robust estimate on the speed to fly and cruise. But the McCready value doesn't correspond well to the thermal strength we want to stop for. The purpose of the secretary problem is to give us a robust selection criterion. In the end, our algorithm for thermal selection is something like this. 1. What is my height band in this area? How low can I get here? And how high does the lift go? 2. Don't stop in the top third unless it's an absolute monster of a climb. Just remember the best Vario readings. 3. Don't stop in the middle third unless the Vario reads higher than it did in the top third. 4. Slow down in the bottom third. Remember that here, a strong thermal may start out weaker. If we need to take a climb in order to continue, the strength doesn't matter. We're constantly thinking about this and adjusting in cruise. And what speed should we fly? Let's take a guess at what the best thermal will be ahead based on the forecast, experience, the flight so far, etc. And take half or 2/3 of that to be the McCready setting. It'll be close enough. Now we have solid and flexible algorithms for flying fast.
To the new pilots, does this help you form a strategy for when to stop for a thermal? And to the experienced pilots, does this match your intuition and experience? I want to know in the comments below. See you in the skies.